how to solve a problem using RAG, okay, resource allocation graph. So for this one, we need to make sure, guys, that. So for this one, first thing that you are going to do is, let's say we have a set of processes, and then let's call it PA. So we have PA process, and it is holding P1, P2 till Pn. Till Pn, okay? You have PA process, a set of process, it is called PA, and it is holding n processes, overall n. Okay? And then you have resource. Resource, you can still call it B or anything. Okay? You have a set of resource, and it is holding R1, R2, basically let's say till R5. Alright? So you have a set of process till like n processes, and you have a set of resource. Basically you have 5 resources. Okay? So it means that since your process is a lot from the resource, it means there is high chance that 2 or more, or like two or three processes, they might be waiting for the same resource, right? So you will try to find, is there any deadlock or not? So for this one, we are going to learn something with edge. Okay, edge. So there are basically 2 types of edges. Okay, request edge and then assignment edge. So let me explain a little bit, and then when solving the problem, it will get clear. Okay. So always remember, your process will be always circular, and the resource will be always the rectangular or square. Okay. In the problem, it will be always. If you see the circle, it means it is a process. If you see the rectangular or square, it means it is a resource. And then if you see 2 dots, 3 dots, or 5 dots inside the square, it means you have 5 copies or 2 copies of the same resource, right? Two of the same resource. It basically means we have 2 from this resource. Okay. And then okay. So this is your process. So this is your, always it will be your process. Okay. And then this one, it is resource. Okay. So if you see this one, 1, 2, or 3, it basically means, so it is not written, but will be, it is usually one, like the dot is here, okay? But most of the time they simply don't write. Okay? It basically means there is only one resource. If you don't see the dot, it means there is only one instance of the resource. Okay? If you see 2 or 3, it means there are 3 copies. 3 copies of basically like 3 of the same type of the resource. Okay? Of resource. So your request edge says, so the edge, basically if I'm referring edge, just simply leave like this, okay? So this is the edge. So this is one edge, arrow. So this is another edge, this is another edge, this is another edge, okay? So if you look to the edges, there are 2 types of edges, right? So one type of edge, it is basically, it is coming right from in the middle of the resource, and it is going to the process, right? And the second one, it is going, it is starting from the process and it is going to the resource, okay? So 2 types. The first one is starting from the resource and it is going back to the process. The second type, it is starting from the process and it is going back to the resource, right? So this condition, if the arrow is starting from the process and if it is going to the resource, it means it is requesting resource number 3. So your process number 2, it is requesting resource number 3. So from here you can know that if you see this one, so your circular, if the arrow is going to the resource, so this is the process, this is the resource. If you see things like this, it's coming from the P going to the resource, it means it is request edge. Okay? So edge means just refer it like the arrow, okay? And then we have the second type of arrow. The second type of arrow is that it is starting from the resource and it is going to the P, right? Basically, so it is starting from the here, there will be dot in the middle, and then it will go to the process. Just look right here. This arrow, it is starting from the process and it is going to right here. But the another one, this resource is starting, so you need to put the dot in the middle and you should draw it from the middle, okay? because it should start always from the middle and it should go to the process. So what this means is that this resource, it is assigned to this process. So for this one, this process is asking for this resource. So basically this one is waiting for this resource. This resource, it's pre-assigned to this process. So this one is called assignment. Assignment edge. Okay, this assignment edge. So if you look, so this is the condition. Okay, request edge, it will start from the process and goes to the resource. So basically, the process is requesting this resource, and then the opposite is assignment edge. In this one, the resource is already assigned on this one. So basically, P is holding this resource already. Okay, does that make sense? Yeah.
Any assigned to one resource.
Huh?
Two processes assigned to one resource.
Two process. So you are saying like this. So we have two processes. 1, 2. Process number 1, process number 2. Can it be assigned? So if it is assigned, basically, arrow should start with from the resource, right? So what you can do is that 2 dots, and then you're gonna do like this.
Only one dot.
No. So 1 dot, it means that there is only one resource. You cannot give to both of the processes. Okay. For that purpose, you should have two instances. So 2 of the same resource. So this is resource 3, and then assignment. So this resource number 3. So P1 is holding resource number 3, and P2 is holding for this one. Okay. So basically, if you see the dot is coming from the P. So that's why it is this resource is assigned to this one. Okay. So now, any questions so far?
Yeah.
So this one is called rack, okay? The rack. The rack is basically means resource allocation graph. So the graph. In the exam, if I tell you solve the rack, don't think what is rack, okay? Rack simply means is the graph, okay? So in the exam, you might have, or assignment, you might have the graph like this, okay? So what's gonna happen is that I'm gonna tell you, please write me assignment edges. And then you need to write, okay, the assignment edge, what was the assignment edge? It should start from the process, right? So this is one assignment edge, and this is another one, okay? And you have, and also you need to write down request edge. What was the request? Oh, no, right. Hold on. So this is his request, because it's going from the process. P1 going to the R1, P2 going to the R3. So this is 1, 2. This is 2 request edge. And then I might also ask you, please write me assignment edges. So assignment, it means it will start from the resource, right? So this is 1 assignment. So R2 goes to P2, R2 goes to P1. And then R1 goes to P2, R3 goes to P3. Basically, we have 1, 2, 3, 4. We have 4 assignment edges, and then only 1 and 2, only 2 request edges, okay? Right?
I have a question. Why R4 is a process?
R4, no, it's resource. R4.
Yeah,
So circular, it means it is a resource.
There is a processes P1, P2, P3, and the last is R4.
Oh, it's wrong. It's wrong. It should be. Okay, hold on. We only have 3 processes, so this one is wrong. It should go up. Okay, it should be up. So that's my bad. Basically, if you look R4, you have resource 4, which is available, and you have 3 copies of the R4. Okay. And then in the exam, so I might ask this one, I might ask this one, and plus I might give you, is this a deadlock or not? What do you think? Is this a deadlock or not?
So you have 3 copies of R4, you can use 3 processes, right? It's not deadlock.
Yes, 3 process might have access for this one. So to make it deadlock, basically it should be circular, right? It should be circular, and then they should be like waiting for each other. In this one, if you look, your P3, it is holding R3, but P3 will get executed inside the CPU, right? And after this one, R3 will be available. If R3 is available, P2 will be executed next, right? And then R1 and then R2 will be next, right? So this is going to be no deadlock, okay? And there are second way how you can find deadlock or not. You know, to find the deadlock, you basically can do something like this. You can do something like this. Okay? So you might ask, we have, for example, 3 processes, and it's holding this one, waiting for this one. So if you want, you can find the deadlock through the table. If you want, by looking at the graph, okay? So let's do the same table for this one. Okay, guys, 5 more minutes, and then you can go ahead break. Okay, 5 more minutes. So let's make table for this one. So to make the table, P1, P2, and then P3. So this one is holding, and this one is waiting. Right? Your P1, it is holding R2, right? Your P1 is holding R2, and it is waiting, requesting R1. Your process number 2, that's it, right? Your process number 2, it is holding R2 and R1. R1 and R2. And it is waiting for the, it's requesting R3. So it is holding R1, R2, and it is requesting R3. Process number 3, it is not requesting anything, right? It's simply holding R3. So it is simply holding R3. It is not waiting for anything. Right? So, do you guys have any question, like converting this graph to the table? Do you guys have any question? Yeah, to that? Okay. So, from this one, I might give you, is the deadlock or not? So this is not a deadlock. If you want, you can find it through the graph, or if you want, just make a table like this, so that it will be easier for you to solve the question. Why? Because your R3 is not waiting for anything. So what it means is that R3, once it is inside the CPU, it will not go to the wait mode, right? It will be simply executed. So P3 will be executed, and R3 you have available, right? The resource is available. So if it is available, basically P2 can be executed next, right? So it will not wait for anything. And after that, once R1 and R3 will be available, so basically this one, process number 1 only needs R1, and then this one will be executed next. So there will be basically no deadlock. Понятно? Okay? And then I have another question. So what if it was like this? R2 or R1?
It's really
Deadlock.
connected to
Deadlock. Let's say this is going to be deadlock. So
Yeah.
instead of if P3 if it's waiting for the R2 or R1, it is going to be deadlock, right? Потому что это у нас будет уже замок, да? Это у нас будет как loop. P1 is waiting for the P2, P2 is waiting for the P3, P3 is waiting for the P2. So it would be like circular wait. Okay? This is called deadlock. So guys, let me give you 15 minutes break. 15 minutes break, and come back, and then we have like a lot of problems to solve. Okay?